Well, so I may upload this so everybody can see, okay? Everybody can see what we, maybe you wanna, yeah, you wanna watch later. Okay, so as you know, right, the exam is gonna be cumulative. That's why I'm gonna try to, okay, solve each question, each related with each topic, okay, we covered in the in our course. So the first question, separable equations, if you remember, right? So the question is this one, dy over dx, which is equal x squared y minus 9y over x plus 3. I hope you see my screen, right? There is no problem around. You hear me, right? Please just tell me if you have any problem so that I can help you. Okay. So this is, okay. Since section by section, as you see, right, I separated the question. Since it says the separable, of course, we need to go with the separable equations. Of course, you can use, right, some other techniques to solve this problem, but I'm gonna try to use, right, the separable equation technique. What was the separable equation, guys? If you remember, right, separable equation was something like that. So you need to be able to, right, give me two separate functions, right? Each of them should be given, right, with respect to the other variable, right? F of x times g of y, look at that. I need to be able to write those two functions separately with respect to, right, the different variables. If that's the case, right, I may able to integrate easily. That is why, right, in this case, look at that, in this situation, I need to use the algebra. I need to arrange the terms, right, so that I can get the separable equation. How can I do that? On the left-hand side, you see dy over dx. What I can do on the right-hand side, as you see that I have the y common terms. I'm using just the algebra around, okay, to separate the functions. Y will be, okay, the term outside, x squared minus 9 over x plus 3. As you see now, this is my, right, the g function. This is my, right, the f function. So it is separable, right? At this step, I saw it is separable. It is separable. So now if it is separable, what I can do, I can just move the related terms, right, to the other side. Like in this case, look at that, I need to move the y to the other side, which it will be something like that. And on the right-hand side, look at that, I'm gonna have x squared minus 9 over x plus 3 dx, correct? Good. That is why, okay, separable equation is the one of the best techniques. It gives us, right, directly I can integrate. So now I will integrate to both sides. The left-hand side integration is gonna be so easy, ln but the right-hand side integral is gonna be is gonna create some trouble. But before taking the integral, look at that. I can write the x squared minus y, which is equal x minus 3 times x plus 3. As you see, right, I have the same term, x plus 3 will go away, and then I will just have the x minus 3 term there, right? Now, I have easier integral, which is the integral is going to be equal to x squared over 3 minus, sorry, I need to have here the minus x, 3x plus c, correct? Then, if you want to, of course, go ahead and then give me the explicit solution, that's going to be equal x squared over 2 minus 3x times maybe k, which is e to the c, right? That is the okay answer to this question. Yeah, please, after solving any question, I will just give you a couple seconds if you have any question. Do you have any question about this question, guys? Okay. So the second one, I'm gonna skip. I will choose, okay, to use my time, okay, wisely. I will try to choose, okay, just one question from each section, okay. Let's try to finish all the sections, okay, just solving one question. The second part is, right, the 1.2, right, which is the linear differential equations, it says. So, which is dy over dx plus 3x squared y, which is equal 6x squared. Okay, is that linear, right? First, I need to see if it is linear. Yes, it is linear. As you see, I have the y prime here, y here, right there in the additive combinations, if you remember, and I don't have the right a degree which is bigger than right the one. That's why it is linear. So if it is linear, I saw the linearity, right? It is linear. After that, right, I need to have a standard form. What was the standard form? Standard form is the form you have the y prime alone, as you see here, right? Y prime alone. That is why, yeah, let me write in this way. So y prime is alone. That is why it is in standard form. Perfect. Look at that, right? So I saw both conditions satisfied, right? Now I can use the linearity, linear technique, which was the integrating factor. What it was saying, so first of all, you need to find out a mu function using, right, this formula, right? That's my integrating factor, integration or factor. I need to take this integral, which is going to be equal e to the x cubed, right? That's it. So this is going to be my integral. After finding the integral, what I should do, I should multiply this integral by y. That's going to be my left-hand side. Since if you remember, right, I was trying to have the product rule on the left-hand side so that I can integrate. Now I'm sure, right, after having this mu, if I multiply the left-hand side my differential equation, yeah, it is guaranteed I'm gonna have, right, this term. I hope you remember that one. But of course, I'm gonna multiply, right, e to the x cubed by the right-hand side as well, e to the x cubed, okay? Now, it is time to integrate both sides. So if I integrate both sides, correct? The left-hand side, I have the derivative and the integral. They will kind of cancel each other. E to the x cubed times y. Okay, well, how about to write the integral of the right-hand side, right? To get the integral of the right-hand side, you need to use a couple integration techniques, right? Can I use the substitution? Why not? If I choose the u is equal x cubed, the u is going to be equal 3x squared dx. Do I have 3x squared somewhere? Yes, as you see, right, the 6x squared I have there, which is my, right, the du. So I can just split the 6 2 times 3. Okay, so this is my du part, this is u part, right? My new integral is going to be equal 2 times e to the u du. Is that all right? And now let me take the integral of the right-hand side, which is going to be equal to e to the u plus c, and then e to the x cubed times y on the left-hand side. What was u? U was equal x cubed. So it is equal 2 times e to the x cubed plus c. So if I divide by, right, e to the x cubed, y is going to be equal 2 plus c e to the negative x cubed. So that is going to be my answer to this problem. Do you have any problem, guys, about this question? Do you have any point you missed? Do you feel you understood everything? Okay. The third question is about the exact equations, right? So 1.3 exact equations. So let me solve the first one. 2xy plus x squared dy over dx, which is equal to 0. What I should do first, since the exact equations needs to be given in this form, if you remember, m of xy dx plus n of xy dy, which is equal to 0, right? This is the form. This is the form I need to have for the exact equations. Look at that. This is not similar. This is similar, but there are some things missing around, right? I need to arrange. That is why, right? If I multiply by dx, right? If I multiply by dx, all the terms, right? So I should have 2xy dx plus x squared dy, which is equal to 0. Now look at here, right? This is my m, this is my n. To use the exact equations, first of all, as you know, right, you need to check if it is exact. How am I going to check the exactness? M to the y, right? What is the derivative of m with respect to y? This is my m term. I'm going to take the derivative, right, with respect to y, which is equal to x. N to the x, what is the n, which is equal to x squared? So I need to take this derivative with respect to x, which it is equal, right, to 2x. As you see, since they are equal, right, it is exact. Great. After seeing the exactness, I have two information, right, for my solution I need to use. I know that the derivative, sorry about that, the derivative of big F, which is my solution, right, with respect to x, it should be equal big M. So do I have the M? Yes, I have the M. M is equal to xy. So I need to take the integral of both sides to be able to find the big F, which is going to be integral of 2xy dx with respect to x. So what is the integral of this one? Since you need to take the partial integral, right, with respect to x, which is going to be equal, as you see, x squared y. But I need a constant here, but my constant is going to be function here instead of, right, the constant, the normal constant. That constant, of course, is going to be, right, the variable I kept as a constant in this integral. So it is going to be a function of y, which is my constant. I hope you remember all these steps, right? So now I have almost, right, my solution except this part, h of y. To be able to find, right, what is the h of y, what I will do, I will, right, integrate the solution with respect to y. Look at that, what it says here. So now I have the big F, which is this one, x squared y plus h of y. I need to take its derivative. And then also on the right-hand side, I should have my n. My n was equal x squared. So you should be careful, right, when you take the integral or the partial integral. Okay, those are the points, right? You always make mistakes. So when I take the derivative of x squared y, with respect to y, by the way, right? This is the derivative. With respect to y, this is going to be equal x squared plus h prime y. It should be equal to x squared. So x squared will go away, and then h prime y will be equal to 0. To figure out what the h is, I need to take the integral of both sides, which is going to be equal to c. So at the end of the day, my, right, solution to this problem, since I found, right, the x squared y, and now h of y is just a c, so that is going to be my solution to this problem. Is everything all right? Do you have any question? All right? Okay. If you don't answer any question, I just assume you got each part, guys. Okay, homogeneous equations. So let me choose the second one. So y prime, which is equal x over x minus 4y. What was the homogeneous equation? Let me remind you. when you are given the y prime, of course, you should have a function on the right-hand side. But if you can write the right-hand side as a function of y over x ratio, okay, that's going to be the homogeneous equation, okay? If it is homogeneous, I can use a substitution to solve this problem. But first of all, I need to see if I can write this equation with respect to y over x terms. Let me see, right? To do that, I'm going to arrange the terms. X, 1 minus 4y over x. Look at that, what I did for the bottom. I just took the x out so that I can cancel this, right? And then now look at, I have the y over x term, right? So now I can say, right, this is the homogeneous equation. If it is homogeneous, what am I gonna do? I'm gonna use a substitution. This substitution will help me, right, to turn this one into another problem so that I can solve it. So y is equal xu here. Since I need the y prime here, I need to figure out what the y prime is gonna be, right? Y prime is equal u plus xu prime. Okay, so I'm gonna substitute the y prime on the left-hand side, u plus xu prime, 1 over 1 minus 4u. It seems this integral is not gonna be easy, but let's try it, okay? I don't know if I designed this question right to get the easy integral. Let me see. So after substituting, everything should be given right with respect to the new variable as we did here, guys. U plus xu prime. So I have xu prime on the left-hand side. I'm gonna move the u to the other side, 1 over 1 minus 4u minus u. What I'm expecting after all these, right, the operations, I'm expecting, since look at that, let me tell you, homogeneous equation needs to turn into the separable equation. After using, look at that, this substitution, it needs to turn right into the separable equation. Okay, so 1 minus u times 1 minus 4u, which is gonna be equal u plus 4u squared. And then xu prime here, and then 1 minus 4u, guys, right? It is going to be separable, since look at that. This is the u function and then x function on the left-hand side. Can I write this one in this way? The u 1 minus 4u, right, over 1 minus u plus 4u squared, okay, which is going to be equal on the right-hand side, which is going to be equal dx over x. Is everything all right up to this point? Since the rest is not going to be easy for us, if we decide to solve this integral, I may skip that part. Do you have any problem up to this point? Okay. So as you see, it is separable. I just need to integrate it. So if I integrate the right-hand side, it is going to be ln x plus c, right? The right-hand side. But the left-hand side integral is not easy, guys, okay? If you want me to solve this integral, sorry about that, since I didn't notice that if it was this this type of complex integral here, okay? If you want me to solve, at least I need to, okay, spend maybe 15 minutes, okay, to solve this integral. But we can skip this integral, but trust me, I'm not gonna ask, okay, that type of hard integral in the exam. But I can give you some idea, okay, how you need to solve this problem. You need to split this up first, okay, to take this integral. Let me show it to you. So to take this integral, 1 minus 4u, at least I can give you a couple idea, okay? 4u squared du. You need to, okay, split this up in this way. And for u, okay, 1 minus u plus 4u squared du. So this part, you need to take care of this part either, okay, u is equal tangent theta type of geometric substitution, okay? But this part needs to be, okay, taken care of, okay, by just normal substitution, okay? If you use, okay, t is equal 4u squared minus u plus 1, okay? dt is gonna be equal 8u minus 1. You're gonna need, okay, you are gonna need to have, okay, minus 1, something like that on the top, okay? You can add negative 1 plus 1, and then you can take care of it. Or if you see, okay, you may take, maybe we can find, okay, easier way. Did you see what I saw? 4 minus, yeah. Okay. I think it is easier than I think. Just give me 1 second. Look at that, guys. So can I do this one? Negative 1 plus 1, right? Oh, no. Since still I'm gonna need, right, yeah, sorry, my bad. Just use, okay, all the techniques I wrote here, okay? That's gonna be the technique you need to use. For the first problem, you need to use, okay, u is equal tangent theta, okay? The other part needs to be solved by this one. For u squared minus u plus 1 substitution, okay? Any problem? Any question?
I actually had a question.
Yeah, sure, go ahead.
How do I know that I want to use homogeneous before any other method, or should I test the other methods to see if I can use them and then realize I can't, so then I use homogeneous?
So, yeah, if you are not asked, okay, about the specific questions, specific techniques, okay, you are free to use any techniques. So you may go with, okay, some other techniques, but in this case, either you may use the exact equations or the homogeneous equation. If nobody asks you about the specific question, you are free to use, right, any techniques, and then try, okay, each one, and then see if that works. Of course, you can just, okay, use the easier one. But if you are asked about, okay, specific technique, of course, you need to use the specific technique as in this question, okay? Okay, so that was the first part of our, oh, okay, another one, Bernoulli, sorry, I forgot that part. 1.5, which is about the Bernoulli. Three y prime minus 4y, which is equal xy to the 4, right? So as you see, right, it is almost linear except this term, right? Since I have this term, it makes this, okay, problem Bernoulli. Bernoulli is the equation, you have the y to the n on the right-hand side, okay? If you remember that one, let me remind you the Bernoulli equation. Look at that, qx y to the n, okay? This is Bernoulli, guys. What am I gonna do? I'm just gonna multiply the right-hand side, okay? Or the old equation, sorry. So that first, okay, my first purpose is to cancel, okay, the y to the n term. Okay, if I multiply by y to the negative 4, so that is what I'm gonna have, x. After that, I will use a substitution. U is equal y to the negative 3 substitution, okay? The term here you have, okay, will be your substitution term, guys, y to the negative 3 term. Don't take the all other ones. You may sometimes, okay, take the constant, but don't take the, okay, x functions. It is gonna be mess around, okay? Just take the, okay, y variable, which is the variable with respect to y here. It is gonna be your substitution variable. Okay, if I have the, right, the substitution the y prime here, I need to replace this one by new, with respect to new variable. That is why I'm gonna need the u prime as well. -3 times y to the -4 times y prime, right? If I take the derivative of the right hand and left hand side. As you see, on the right hand side, this is exactly, okay, the term I need here. That is why I chose this, right, as a substitution term. But except the negative, I can move this negative here, right? Okay, so now if I turn this one, if I transform this one into the something new with respect to new variable, it's going to be negative u prime minus 4u, which is equal x. Did you see what happened? I used, right, that substitution. So Bernoulli, right? Bernoulli now turned into a linear equation. Okay, if you remember that, that was the purpose of using the substitution. Any questions so far? So I just used the substitution to get the linear equation. The rest is just the linear equation solution, guys. U prime is gonna be u prime plus 4u, which is equal x. This is the standard form I need, right? I need to have. And I need to use the integrating factor e to the 4 dx, which is equal e to the 4x. E to the 4x times y prime, which is equal e to the 4x times x. I multiplied, right, both sides by integrating factor. Now it is time to take the integral. E to the 4x times y, which is, right, e to the 4x times x dx. So the right-hand side integral, right, should be handled by integrating factor. So u, right, the rest is gonna be, let me write in this way so that you can see better. X times e to the 4x. This is my u, this is my dv, right? U is equal x, du is equal dx. And e to the 4x dx, which is equal dv. And v is gonna be equal 1 over 4 e to the 4x, right? So u times v, x times 1 over 4 e to the 4x minus v times du. V times du, 1 over 4 e to the 4x dx. And then e to the 4xy here on the left-hand side. So y is going to be equal then x e to the 4x over 4. This is my first term. And then the integral of this one is going to be 1 over 16 e to the 4x. But look at that, I had the e to the 4x. That's why I'm going to move that one to the other side. And then also I need to have here, right, the SC. Is there any problem? I hope you see the process, right? You saw the process. I just use a substitution. I turn my equation into the the linear equation. Then I use the integrating factor to solve it. How's it going? Do you have any questions so far, guys? I can. So this is the as you remember, right? This is the end of chapter 2, right? Before the second order differential equations. So now I have the other techniques for the second order differential equation. Okay. From chapter 2 now, I will choose, okay, the first one. Which one you want me to solve? Write down the form, okay, particular solution. Yeah, we can solve one of those, and then we can solve one of the other ones. Right, okay, let me solve the first one. Y second prime minus 3y prime minus 4y, which is equal to 3t e to the 4t. So this is the second order, and then what I have on the right-hand side, polynomial times exponential type of function. When you solve the second order differential equation using the undetermined coefficient technique, what you should do first, right, you should solve the auxiliary equation, r squared minus 3r minus 4, which is equal 0. So r minus 4, and then r minus plus 1, which is equal 0. I have these rules. R1 is equal 4, R2 is equal negative 1. Why did I do that? Since I'm going to compare, right, this guy, which is my R, with one of my, right, the roots. As you see, right, this is R is equal 4 is a root of auxiliary equation. That is why I need to be careful when I choose my particular solution. My particular solution, first of all, I need to have AT plus B e to the 4t here. But since I have an equal root, I'm just going to have here, right, the t to the s equal 1 term. S equal 1 because of this reason. You remember this part, right? You always need to, okay, take care of, right, second order equations in this way if you use undetermined coefficient technique. Don't forget this extra term. So now I will go ahead and I will solve the problem. But first, let me, okay, multiply this AT squared plus BT e to the 4t, right? I'm going to need my first and then second derivative. Yp prime is going to be equal this one, the derivative to AT plus B e to the 4t, and for AT squared plus BT e to the 4t. And the second prime is going to be, right, the derivative of this one, 2a times e to the 4t plus 4 times 2at plus b e to the 4t and plus 16, right, at squared. Okay, let me take the first of this derivative. The derivative of this one is going to be equal 4 times 2at plus b again, e to the 4t plus 16 at squared plus bt e to the 4t. So what I should do, I should multiply, right, the coefficients, negative 3 here, negative 3, look at that, negative 12. And I am going to need here the negative 4. If I collect all the terms, right, I have 3 different terms around. At squared, as you see here, I have at squared, and then at squared I have here. If you add them up, look at the 16, negative 12, and then negative 4, they will cancel each other, right? They will cancel each other. And what else I have around, right? Bt, t to the e, t times e to the 4t terms. So here I have e to the t times e to the 4t term, t times e to the 4t term. So negative 6a plus, sorry, negative 4 b from the first line, negative 6a from the second line, also negative 12b, this one right here. What else here? I have 8a, another 8a, and I also have the 16b, right? T e to the 4t, which it needs to be equal, right? The 3t e to the 4t. Correct? Did I miss anything? So I have negative 3b here, negative 3b, and I have 2a, And 8b, guys, look at that, 4b plus 8b. That's it, I think, right? It's just gonna be equal 0. Right? So you can write in this way, since that was the term e to the 4t, but I don't have the constant e to the 4t on the right-hand side. That is why I can write it this way, e to the 4t. So now it is time to solve for the a and b. From the first one, I have 8a, and minus 6a, which is 10a, right? 16b, and okay, they will cancel. Well, look at that, that's good. So 10a t e to the 4t, which is equal 3t e to the 4t. From here, a is gonna be equal 3 over n, 10, sorry. And from here, look at that, I have 8b negative 3b, which is 5b plus 2a should be equal 0. And then b is gonna be equal negative 6 over 50, right? If you use the 3 over 10 multiplied by 2, and then just send to the other side. So my particular solution then is gonna be equal t times a to the at plus b, it was at plus b, 3t over 10 minus 6 over 50, right? Okay, that's my solution. Of course, you are gonna need, right, the yh, c1 e to the 4t plus c2 e to the negative t. And then to get the general equation, just add these, right, to get the general solution, yp plus yh. Any problem, guys? I hope you remember each step and how I choose to write my particular solution, and then how I use my extra term there. Okay. So maybe I can write solve another problem in this section. So look at the 4, number 4. Number 4 is this one, y second prime plus 2y prime plus 2y, which is equal 3e to the negative t sine t plus 3t cubed e to the negative t cosine t. So this is the question. We don't need to solve it, right? We just need to give the particular solution, guys. Please don't solve it, okay, since it takes a lot of time. I just need to give the y prime. But the y prime, since I have looked at the 2 different functions here, f1 and then f2, I need to use the superposition principle. So if I have the f1, which is equal, right, which is equal 3e to the negative t sine t, correct? I need to choose my yp in a way, right? I need to cover these functions. But of course, you can say that, right? Where is my auxiliary equation solution? Auxiliary equation is going to be equal r squared minus 2r plus 2r plus 2, which is equal 0. And this is, as you see, right? It cannot be factorable. So the roots are going to be r1 and then r2, which is equal negative b, negative 1, right? The negative minus square root b squared, which is going to be equal negative 4. So negative 2 here, right? Over 2, which is negative 1 minus plus I. Okay, that's going to be my roots, the auxiliary equation roots. If my auxiliary equation roots, okay, are the negative 1 and minus plus I need to check out, right, if I have the similar alpha plus I beta in my function. As you see, this is my alpha, which is negative 1. And then this is my beta, which is 1. Alpha plus I beta, which is equal negative 1 plus I. As you see, it matches one of the my roots. That's why you need to have f equal 1 here. F equal 1, since it is one of my roots. Is there any problem here? But for the rest, For the rest, what I will do, I will just use the exponential and then trigonometric functions to set my the particular solution. A sine t plus b cosine t. So I will do the same thing for the f2, guys. f2t, which is equal 3t cubed e to the negative t cosine t. I look at that, alpha plus I beta, which is same here, negative 1 plus I. That is why f equal 1, since it is one of my roots, right? So yp2 is going to be equal this way. Okay. I need an extra term since f equal 1. But inside, what I have, as you see, I have the third degree polynomial, at cubed plus bt squared plus the ct plus d times what? Times cosine t. Don't forget the e to the negative t, as I did. And then also e to the negative t, right? Et cubed plus ft squared plus gt plus h. Sorry, I don't have enough space here, right? Oh, sorry, I have sine t. Okay, that's gonna be my particular solution, right? For the yp. So that's how you need to solve this type of problem. You just need to provide the form of the solution. That's it. You don't need to solve it. Any questions so far, guys? Okay, the next section is about the variational parameters. Right? Let me solve one of these. Variational parameters. So I will solve the second question. Which is equal t minus 2 e to the t. What I will need, I will need first the homogeneous equation solution. To do that, I'm going to need auxiliary equation. Auxiliary equation is equal r squared minus 2r plus 1 in this case. So I have to write the same root, r1, 2 is equal 1. That is why my homogeneous part of the solution is equal c1 e to the t plus c2 t e to the t. After having the homogeneous equation solution, my particular solution should be designed just changing these constant by variables. v1 e to the t plus v2 t e to the t. Okay. So I'm hoping I can find the v1 and the v2 since I don't know what they are. That is my purpose. I'm going to be able to find. So I'm hoping I need to find the v1 and the v2. How am I going to do that? I was using the two equation, from the assumption, if you remember, equation 1 and then equation 2. Equation 1 is this one, y prime, v1 prime e to the t, v2 prime t e to the t, which should be 0. So I'm going to take the derivative, look at that, and I'm going to keep these y1 and then y2 same. And then I'm going to take their derivative, v1 prime e to the t derivative, which is e to the t. And then v2 prime, the derivative of t e to the t, which is equal e to the t plus t e to the t, which is equal, it needs to be equal, the right-hand side of my functions. It was e to the t over t squared. Over a, which is, a is equal 1 in this case. Any problems so far? So now I will use the linear system of equation to solve this problem. From the equation 1, v1 prime, if I pull the v1 prime out, that would be equal negative t v2 prime, since I can cancel the e to the t, if I put the right v2 prime term to the other side. If I use this one, right, in equation 2, so I'm going to use this one in equation 2. So since I have the v1 prime, look at here. So just replace, right, this term in equation 2, which is going to be equal negative t e to the t v2 prime plus v2 prime e to the t plus v2 prime t e to the t, which is equal e to the t over t squared. I have some terms here I can cancel. Look at that. They're going to cancel each other. So v2 prime e to the t, which is equal e to the t over t squared. E to the t will cancel. And then v2 prime, which is equal 1 over t squared. And then v2, if you integrate it, it is going to be equal negative 1 over t. Right? And I need to find out, yes, I found, right, what the v2 is. I need to find out what the v1 prime, what the v1 is. To do that, I have just the v1 prime here. v1 prime is equal negative t times v2 prime. I have the v2 prime here, so I can just use directly. T will go away, negative 1 over t. So from here, v1 is going to be equal negative ln t. Okay? That's how I'm going to find the v1 and then v2, and then just substitute them back to get the what the yp is. Yp is equal negative ln t e to the t plus negative 1 over t times t e to the t. And then h is equal c1 e to the t plus c2 t e to the t. Is that all right? Do you have any questions so far, guys? No question? No response? Okay. So the last section is gonna be the Laplace transformation, guys. So the first question is about, right, the inverse Laplace. So chapter 7, Laplace. The first question is this one, f of s, which is equal s plus 7 over s squared times s squared plus 8s plus 17. Okay. If I want to take the inverse of this one, what I should do? What techniques would you use, right? There is no specific technique stated here. I will go with the, not convolutions, it's convolution. You may use a convolution as well, but it is going to be harder than the partial fraction in this case. I will use the partial fraction, okay, for this problem, guys. But it will take time, okay, to use the partial fraction. Since you cannot use, right, the table directly for this type of question, that's why the partial fraction is going to be the suitable technique. Okay, to do that, first of all, you should notice that, okay, to be able to use the table, we always try to convert the terms in a form I can use the table. In the table, to be able to use the cosine and then sine related formula, I will always need, right, something like that, as you know. That is why this term, right, I'm gonna convert this term into this. 8s, 17 can be written in this way. 16 plus 1, okay? So this part would be s plus 4 squared plus 1. So I'm gonna use that part here, s plus 4 squared plus 1. I have s squared here, a over s. Do I need another, right, the factor here for s squared? Yes, guys, right? This is the right multiple factor. You don't have just the simple factor. You have the repeated factor. That's why it's going to be s squared. and plus, right, what you are going to have CS plus D and S plus 4 squared plus 1 you are going to have. So what you should do, you should solve all the coefficients, but I don't want to spend my time, okay, since my limited time for finding, okay, all these coefficients, okay. You just need to use the partial fractions, and then you just need to, okay, solve for C and D. Instead of that, okay, let's try to take the inverse of this one. So inverse of this, right, would be this. Inverse of this term, look at that. Inverse of this term, and then inverse of this term. I'm just gonna show you, okay, the shortest way. So skipping the finding the coefficient. A over S, which is just A, right? If you use just the table. So by the way, as you know, right, you can use your Laplace table in final exam. A over S is just A, right? The inverse of it. So my F of T here, A. The inverse of B over S squared, which is equal BT, correct? If you look at the table, the Laplace of T is equal 1 over S squared. But when you look at, right, this part, of course, without finding the C and D, okay, it is not going to be correct to do that. But basically, you should do this, guys, okay? By accepting, you find the coefficient, and then you do the, okay, regulations, okay? You are going to need to have the S plus 4 on the top, and then on the bottom in this way, S plus 4 squared plus 1. And, okay, of course, you are going to have another coefficient here, not the D here, okay, F, S plus 4 squared plus 1. Why do I do that? Since I know, right, from table, look at that, this part will correspond to, right, e to the negative 4t cosine t type of, right, transformation. And then this part is going to be, right, is going to correspond to e to the negative 4t times sine t transformation. Okay, that's why I need to regulate this part S plus 4, okay, so that you need to match with this S plus 4, okay? To do that, of course, you are going to use, right, some algebra to take care of that part with the numbers, okay? That's all you need to do. Any question about this one? You don't want to say anything? Okay. So, okay, I'm not sure, right? Okay, look at that. We have here 3, 4, 5, 6, okay, some questions, but the questions about the integral differential equation, I'm not sure if you had, since I saw maybe a couple questions there, okay, you might not have had, okay, enough exercise for that part. If you want me to solve, okay, that I can solve, I can just go through the integral differential equation part. Or before that, look at that, there is a convolution problem there. Let me start by that one. To F. So y second prime plus 9y, which is equal e to the 2t. y0 is equal 0. Now y prime 0 is equal 0. But it says, okay, you need to use the convolution theorem. What was the convolution theorem, right? Basically, when you take the inverse, if you have the right, the two function, look at that, that inverse should be taken by using the convolution in this way. That's the part I'm going to be using, right, in my differential equation. So let me use, okay, first the Laplace first, right? Laplace transformation. The Laplace of y second prime, as you know, s squared y of s minus s y 0 minus y prime 0. and then plus 9 y of s. And then the Laplace of the right-hand side, which is equal 1 over s minus 2. If I use the initial values, 0, 0, 0, 0, so y of s on the left-hand side will be this one, s squared plus 9, which is equal 1 over s minus 2. As you know, my second step always is to find out what is my y of s, which is going to be equal 1 over s minus 2, s squared plus 9. Okay, so I have the y of s. To figure out what the y of t, which is my solution, right, I need to take the inverse of it. To take the inverse, you can use, right, either partial fraction or convolution. In this case, we want to use the convolution. Look at that, the inverse of 1 over s minus 2 times 1 over s squared plus 9. As in the convolution theorem, look at that, this is my big of fs, this is my big G. What I will do, I will take the inverse of it. The inverse of this one is going to be equal e to the 2t. So I'm going to have here the e to the 2t. And then the inverse of this one is going to be equal sine 3t. Okay, convolution by the sine 3t. So my solution then is going to be, right, y of t is equal e to the 3t convolution by, sorry, e to the 2t, right? My bad. E to the 2t sine 3t. You can't leave in this way. What you should do, right, you should use the convolution definition to take care of, right, this convolution using the integral. If you remember, right, you need to switch the first function by v, and then you need to shift the second function by v. I will do the other way around, since it is going to be easier to do that. So sine 3v, I'm going to switch e to the 2t minus v, guys, which you need to take, right, the integral with respect to v, not t. Any problem so far? Do you have any issue with the convolution? So the rest of the problem is to take this integral, guys. Okay. So what I can do here, I can just split this up, e to the t, e to the negative 2v, right? So my integral is not about the, right, the v term, so that I can take this out, right? It is just kind of, right, the constant term. E to the 2t, 0 to the t, sine 3v times e to the negative 2v dv. Okay, so this integral, right, you need to use, right, what? Say again? So you need to use, right, the integration by parts. I'm not sure if you want me to take this one, okay? You just need to use, right, u and then dv, but it is already v. Okay, let me use the dm. So, and then you should use, right, the formula u times v minus v du, okay, to take care of this integral. But I will not do that, okay? Just take this integral. I'm gonna leave it to you. So this is gonna be my solution to this problem. Are you all right? So I have, okay, look at the last question, okay, before the integral differential equation. The last question, the third one, is this one. Y second prime minus 5y prime plus 6y, which is equal g of t, guys. And I have a couple initial values here, y of 0, and y prime is 0 is equal 9. So look at that. The problem here, right, is we don't know anything about the g of t on the right-hand side. Although we don't know anything about that, we can try to solve it, right? If you knew it, you can just substitute into the solution and then solve for the, right, that integral, which we are going to have soon at the end of, right, the solution. As you did in previous example, you ended up having, right, an integral, since you need to use a convolution. It doesn't matter what type of function you have on the right-hand side. at the end of the day, right, you need to take the integral of that function. That's why, okay, we don't care about what g of t is. So I'm going to use the Laplace. The Laplace of the right-hand side is equal s squared y of s minus s y0 minus y prime 0, and then minus 5, minus 5 times s y of s minus y0 plus 6y of s. And the Laplace of g of t is equal, right, to just g of s, right? Since I don't know what that is. y0 is equal to, y prime 0 is equal 9, y0 is equal to, I have y of s terms here, right? They are common. S squared minus 5s plus 6 I have here. I had here, look at that, added to s. And then I have here plus 10 minus 9, which is equal plus 1 g of s. Then y of s would be equal, right, to g of s plus 2s minus 1, correct? 2s minus 1. And over, right, over s squared minus 5s plus 6 and s squared minus 5s plus 6. Did you see that? Is there anything here? Do you have any problems so far? So now I need to take the inverse of the both sides. The inverse of the left-hand side is gonna be equal, of course, y of t. Look at here, right? You cannot take the inverse of this term, right, using the partial fraction. You need to use a convolution. As you see that I have two functions here, g of s over s squared minus 5s plus 6. But, okay, let me write here, g of s times 1 over s squared minus 5s plus 6, right? I'm gonna take the inverse of this one using convolution. When you take when you use a convolution, you are gonna need the inverse of this term, which is g of t, right, the small g. What is the inverse of this one, right? The 1 over s squared minus 5s plus 6. The inverse of 1 over s squared minus 5s plus 6. This can be written, right, s minus 3 times s minus 2. Okay, so I can use one of the convolution feature, since, right, I can see this one, right, as a separate function as well. You see, this is one function, this is another function. This time I'm gonna have, right, the two different convolution here. The inverse of this term is gonna be equal e to the 3t. The inverse of this term is gonna be equal e to the 2t, guys. So my convolution for this part is gonna be equal g of t, right? E to the 3t convolution by e to the 2t, okay? Don't worry about it. I'm not gonna ask two convolution in the final exam, okay? This is just the example, okay, we just had here. So since solving the integral of this type of convolution would take a lot of time. And then the rest, of course, the inverse of this part needs to be taken care of, right? With the other techniques, 2s minus 1, s minus 3 times s minus 2. What you will do, right, you will just use the partial fraction for this part, partial fraction, and then continue. But that's not about, okay, what I do here. Look at it, I just want to show you this part. As you see here, right, this convolution, since you can take okay, first part, since I can just use the composition part of the convolution, this should be given in this way, 0 to the t, g of v, and e to the 3 t minus v dv. And then also look at that I have another convolution here, Still, I didn't take care of it. Plus the inverse of the second term. Look at that. Can I take this integral, guys? I cannot. Why? Since as long as I don't know, okay, unless I don't know what the g of a is, I cannot take this integral. What you should do, you should just leave, okay, in this way. So this is the end of the question, actually, okay? So for this part, of course, you are gonna continue, okay, in this part, and then you need to take the partial fraction to be able to find the inverse. But for this part, for the g of t part, you need to leave the integral since you don't know how to solve the integral. Is that all right? Do you have any question? Since I'm gonna share this document with you guys, okay, after this review, don't worry, I'm gonna put under my course so you can download and then you can just see the solutions. Okay, one last problem let's solve, right? Integral differential equation. The d, 2d, y prime of t minus 2, 0 to the t, e to the t minus v times y of v dv, which is equal t, and now y0 is equal to. So if you look at, right, this differential equation, I have an integral as well. But this integral, right, is given in the form I can use the convolution. If you look at, right, this function, right, was given with respect to v. That is why, right, I can write this integral in this convolution, e to the t. I'm hoping, okay, you don't have any problem, okay, seeing this integral in the convolution form, right? That's the part, if you are given the right integral differential equation, you need to convert that integral into a convolution problem. Then, of course, I will, okay, continue and use the same way as I do for the other question, as I did for the other question. I'm gonna take the right Laplace of everything. The Laplace of y prime is equal s minus y of s, which is equal y0, and then minus, right, the Laplace of, right, this part is gonna be equal y of s times 1 over s minus 1. So for this part, I used, right, the first part of the convolution theorem, guys. And then t, the Laplace of t, which is equal 1 over s squared. So y0 was equal to, okay, y0 is equal to, I have the y of s terms here, s minus 2, minus 2, sorry, my bad, I had 1, sorry guys. I had 2 over s minus 1 right here. These are the terms, right, that are common in y of s, and then minus 2, which is equal 1 over s squared. Okay, what I can do, I can move this one to the other side. So, and then I can make these denominators same on the left-hand side as well. So y of s is going to be equal s squared minus s minus 2 over s minus 1. Correct. And 1 over s squared plus 2. So y of s, let me finish this part first. 1 plus 2s squared over s squared, you see? So now if I move the left-hand side term to the right-hand side, that would be equal this one. 1 plus 2s squared times s minus 1 over s squared times s squared minus s minus 2. Did you see? I found my y of s. Now, I will start, right, to taking the inverse of each term. But before that, right, I can use the algebra to take care of some terms around. Since, as far as I see, right, I can factor this one. Can I factor this one? No, I can factor, but I cannot cancel by the term, I think, the s minus 1. S minus 2 times s plus 1 here, right? This is the one I have. S plus 1, s minus 2 times s plus 1. I told you I can cancel by s minus 1, but it is the s plus 1, right? I cannot cancel that out. So now what I have here, y of s is equal all these terms. That is why, right? Okay, let me write in this way, but I am not sure if we can finish this. It requires a lot of partial fraction techniques here. 1 plus 2s squared times s minus 1 over s squared times s minus 2 s plus 1. You may try, right, to split this up a little bit, but the best way is going to be the partial fraction in this case instead of the convolution. You can try the convolution, but convolution will be longer than the partial fraction. What you should do this: a over s plus b over s squared plus c over s minus 2 plus d over s plus 1, right? This is how you need to take care of, right, this inverse. I will leave the finding the coefficients to you, okay? That's a lot of algebra problem. And then if I take, right, these inverse, as you see, a over s, which is going to be equal a after taking the inverse, and then bt plus ce to the 2t plus de to the negative t is going to be my, right, solution to this integral differential equation, okay? So you just need to find out, right, the coefficients using the partial fraction techniques, and then that's going to be your solution after finding the inverse Laplace. Any question so far? Is everything all right, guys? Okay, so if you don't have any question, I'm just gonna stop here since I saw, okay, most of the question, okay, here, maybe just, okay, a couple questions around I left to you. Please, okay, just let me know if you have any problem about these solutions and then questions, just you can send an email to me after this session, okay? And then I can try to answer your questions by an email. And the questions you will be asked in final exam, which is gonna be, and you know my style, since you got 3 exams, okay? It is gonna be mostly 90% of the questions, okay, in the exam will be similar to, okay, what you had or what you have now in this review, okay, guys? So just try to solve all the questions provided so far, and exam questions, review questions, okay, practice homeworks, okay? So you are gonna be fine for my final exam. If you don't have any question, guys, I'm gonna stop here and I'm gonna close my screen and then stop sharing. Any question?
Do you have the rest of the answers for the rest of the exam review?
I think I just, okay, I didn't solve a couple questions. I think I have somewhere, okay? I put the my course, just go through the my course and then you can find out and then let me see if it is there, okay? Any other question? Okay, thank you so much, okay, for coming this review session, guys. Please stay safe, okay, and then see you in the exam. Have a nice one.